Solve the following quadratic equation for x. 3 square root of 3x square plus of 7x minus of 2 times square root of 3, and this is equal to 0. So basically we need to solve this given quadratic equation, or in other words we are trying to find the roots for this quadratic equation with irrational coefficient and irrational term. So as we have seen in our earlier videos, whenever we talk about finding the roots, we have two important tools in our hands. And what are those tools? One is the not so famous factorization method. And second one, the famous, our beloved quadratic formula. You can definitely go ahead and try using this quadratic formula to find the roots of this given equation. You know what the expression is? Negative b plus n minus square root of discriminant divided by 2a. Find a, b and c, that is coefficient of x square, coefficient of x and the constant value. Substitute here and get your answer. But sometimes, what happens? The calculations involved here, the process, the steps involved here while using quadratic formula to find the roots are a little trickier. They are untidy and they may lead you to making calculation mistakes. So in order to avoid that, sometimes we prefer using factorization over quadratic formula in order to avoid those calculation mistakes and solve this question easily. Let's justify ourselves. Let's actually solve this question using factorization method rather than quadratic formula. If we are talking about factorization, first of all, do we have any common factors to pull out from the left hand side? I don't think so. There aren't any common factors. So the next step is to look for splitting the middle term in order to factorize it. By splitting the middle term, I mean we are looking for two numbers. Let's say the numbers are p and q, such that their sum is equal to coefficient of x, that is positive 7, and their product, that is p times q, is equal to the product of this constant value and the coefficient of x square, that is 3 times square root of 3 times negative 2 times square root of 3. And this is where the magic happens, because initially when we would have seen this, we might have thought, how can we even think of splitting the middle term, because we have irrational coefficients. But the moment we would multiply this, we would get 3 times negative 2 is negative 6, and square root of 3 times square root of 3 is a rational value 3. And negative 6 times 3 is negative 18, which is indeed a rational number. Now we are looking for two numbers whose sum is 7 and whose product is negative 18, which is actually easier now. What can be those numbers? So we can think in terms of factors of 18, which are actually 1, 2, 3, 6, 9 and 18. We are open to use positive and negative signs. We can associate positive and negative signs along with the factors. The only thing is it should satisfy these two conditions. So in our case, let's pick 2 and 9. 2 and 9. And if you are having trouble in picking the factors, pause the video here and see few videos where we have introduced this concept of splitting the middle term, where we have elaborately mentioned how do we pick two such numbers. As in this case, since this product is negative, one of them would be negative. So let's say that we are picking negative 2 and 9. Negative 2 plus 9 is 7 and negative 2 times 9 is negative 18. So these are our numbers that we are looking for. Using this, now let's split the middle term. So we would get 3 times square root of 3x square minus 2x plus of 9x. And you could have written 9x first and then negative 2x. It wouldn't have made any difference. You would still get the same answer. And then we have minus of 2 times square root of 3, and this is equal to 0. Now let's pick up any common factors from the first two terms. There is only one common factor, x itself. So let's pull that out. So this would give us x times 3 times square root of 3x minus 2 plus of, now is the another interesting part. Can you look for any common factors in the last two terms, in both of these terms? At the first glance, you may say no, but let's see. Now 2 can't be a common factor because 2 is an even number and 9 is an odd number. So 2 can never be a factor of 9. But what about square root of 3? Can we write 9 in terms of square root of 3? And as we just saw here, square root of 3 times square root of 3 is 3. And we know that 9 is actually 3 times 3. So this can be split as 3 times square root of 3 times square root of 3. So it means that square root of 3 is actually a factor of 9. So let's pull that out. So if we would pick out square root of 3, what are we left with? So 9x, after pulling square root of 3 out, we would be left with 3 times square root of 3. So this would be 3 times square root of 3 times x minus of 2, and this is equal to 0. And you can verify this by seeing that whether this factor and this factor, are they same or not? If yes, then you would have done it correctly. So now, since 3 times square root of 3x minus 2 is the common factor, let's pull that out. So we would get 3 times square root of 3x minus 2, and the remaining thing, let's write that x plus square root of 3. So we are almost done now. Now if this thing is equal to 0, either this is equal to 0 or this factor is equal to 0. So if x plus square root of 3 is equal to 0, let me first create some space. Okay, so if x plus square root of 3 is equal to 0, if we would subtract square root of 3 from both the sides, x is equal to negative square root of 3, which is one of the values which would satisfy our initial quadratic equation. And secondly, if 3 times square root of 3x minus 2, if this is equal to 0, let's find the value of x. We can first add 2 to both the sides. So this would give us 3 times square root of 3x is equal to 2. Now we can divide both sides by 3 times square root of 3, which would finally give us x as 2 upon 3 times square root of 3. You can further rationalize this to get a rational denominator, but I think you got an idea what the second value of x is, which would satisfy the given quadratic equation. So these are the two values, and I don't think the entire process was very hectic. It's your choice. You can always go ahead and use quadratic formula, but sometimes if they specifically mention that use factorization to find the roots, then you are stuck. So you should be very okay, very comfortable with using factorization along with using quadratic formula. That's all for this video. Bye-bye.